Hello friends, welcome to SahuStudies. In this video, I am going to discuss difference between reduced by key and combined by key in PySpark. So let's discuss about reduced by key. Reduced by key is a transformation function. It is a wider transformation. Wider transformation means data will going to shuffle across different executors over the network. It is used to merge the value of each key. It uses associative reduce function on PySpark RDD to merge the value of each key. It is a wider transformation, hence it shuffles the data across different partitions. It operates on pair RDD, that is in the form of key and the value. It is very useful when there is a requirement to perform aggregate function on the values which are associated with each keys. One of the main advantages of reduce by key is that it reduces the amount of data that needs to be shuffled and stored in the memory. One of the main disadvantages of reduce by key is that it required the reduce function that is associative and cumulative, which may not be the case for all aggregate function. Let's understand the reduce by key with the help of this pictorial representation. So suppose there are three partitions and these are the data points which are present in this partition, right? So whenever we are going to use reduce by key, then the aggregate function first implemented in each and every partition, or you can say aggregation function is going to implement locally. So suppose we are using the sum aggregation function. So here what is it's doing, it is doing the aggregation per key label. So this is the key and this is the value, this is the key and this is the value. So there's only one data points, that's why the value looks like this. So in this partition there are two values for key A and two values for key B. When the aggregation function is applied over this partition, the data becomes like this. Key A key has value 2, B key has value 2. Here there are three data points for key A and B, and when the aggregates applied over this partition, the sum aggregates, the data points be converted like this. A is the key and the value of that key is 3. B is the key and the value of that key is 3. When the aggregate function applied on each and every partition, then the shuffling of the data is taking place. And the shuffling of the data is taking place at the very last stage of the transformation. And this data point is coming from here. This data point is coming from this partition. This data point is coming from this partition. This data point is coming from this partition. This data point is coming from this partition, and this data point is coming from this partition. These data points are available after shuffling. So data is shuffling from these three partitions in these two partitions. Once the data is shuffled and present in the partition, again the sub-aggregate function is going to applied here, and the data points become like this. The key is A, the total value is 6. Same here, sub-aggregate function will going to apply in this partition, and the data point become like this. This is the result, and the result is B, as B is the key and the total value is 6. So here we have seen that reduced function first apply the aggregate function locally or on the each and every partition, then shuffles the data. When the data shuffles in again the different partition, then again aggregate function applied and it will create the final output. Let's discuss about combine by key. Combine by key is a transformation function. It performs transformational operation on the pair RDD. It requires shuffle operation at the last stage. It is generic function to combine the element of each key using custom set of aggregate function. One of the main objective of combined by key transformation is that it transforms pair RDD, that is key and the value pair, to RDD, which is key and C. This C is nothing but it is the result of any aggregation. If there is a requirement to perform custom aggregation on the values of pair RDD while providing the fine-grained control over the aggregation process, then we should use combined by key. It allows to specify three functions. Whenever we are going to use combined by key, it takes three parameters as an argument, and those three parameters are the functions. One is the initial value, second is the combination function for values within the partition, and third function is for merge function to combining result across different partition. So let's understand the combined by key function with the help of this pictorial representation. This pictorial representation is same as the reduced by key because the internal functionality is same. So these are the three partition. Data points are present in this partition. Some aggregates applied locally. So suppose this is some aggregates we are doing with the help of a combined by key. Some aggregates is apply individually on each and every partition, and the data points are converted like this. This is nothing but we are adding the value in each key. Once the some aggregate applied on each and every partition, then the shuffling of the data is happening, and it's come into the different partition which may be present in different executor. And when the data points are there, so this data point is coming from this partition, this data point is coming from the result of this partition, and this data point is coming from the result of this partition. Same for the B, this one and this one. This is coming from here. This B2, this one is coming from here. This B3 is coming from here. And once the data gets shuffled and present in the different partition, again this aggregate function applied in this partition and gets the final output. So this is the final output, A, 6. A is the key and 6 is the cumulative aggregate function on the value which is present here. So we are applying some aggregate, so it is giving the addition. Here same, B is the key and 6 is the total sum value of key which is present here. So let's discuss what is the difference, right? So let's talk about the reduced by key. It is more suitable for cumulative and associative reduction operation on the values. It performs the logical operation on each partition before shuffling. It required less memory. It has limited flexibility because it has fixed reduction functions. Provides better performance due to local aggregation. Let's talk about the combined by key. It allows more flexibility in custom aggregation logic. It allows to specify functions for creating an individual value, merging values, and merging values across partition. It offers more control over memory uses and performance by defining appropriate aggregation functions. It requires more effort in implementation. In this video, we have seen what is the difference between reduced by key and combined by key. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.